Na, 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 na. Okay, we are live here. Okay, everything seems fine here. Okay, so now in this stream, what we do is simply we are gonna we're gonna start the accessibility topic of our HTML. Now inside this topic we have actually 26 steps to complete. There are multiple videos of important lecture and content. So here importance of accessibility and good HTML structure. There are multiple lectures here. What is accessibility? What are the screen readers and who uses them? And similar videos. Now we are gonna go through each one of them, and after that we are gonna build a checkout page here, and after that we will try to finish all this stuff here. And lastly, this is HTML review. We are gonna do this. So this is gonna be a long section. So this may take a while. You don't have to waste any time. Okay. Okay. So we are good to go. Let's start.
What is accessibility? Accessibility involves creating products and services that everyone can use. In the context of web development, it's making websites that everyone can understand and interact with, including people with visual, auditory, motor, and cognitive disabilities. Some examples of disabilities that can impact users' online experience include blindness, low vision, color blindness, deafness, difficulty using keyboards, mice, or touchscreens, attention disorders, memory issues, difficulty speaking or understanding spoken language, and sensitivity to flashing lights. These are just a few of many conditions that can impact users around the world. To help you create accessible websites, the World Wide Web Consortium, known as W3C, developed a set of international standards that you can follow to make your websites more accessible and easier to use for people with disabilities. These standards are known as the Web Content Accessibility Guidelines, WCAG. These guidelines are designed with four core principles in mind, known as POUR. P-O-U-R. P stands for perceivable. Users must be able to perceive the information that you are presenting. For example, you can provide alternative text for images, so users who access your website with a screen reader can understand them. O stands for operable. Users must be able to interact with the user interface. For example, you can make sure that all functionality is accessible through the keyboard too, not just the mouse. U stands for understandable. Users must be able to understand the information. For example, you can avoid complex sentences and use simple language as much as possible. And finally, R stands for robust. A wide range of browsers and other tools, including assistive technologies, must be able to interpret the content. Using semantic HTML is very helpful for making your website compatible with different browsers and assistive technologies. If your content doesn't follow any one of these core principles, not everyone will be able to use your website. To check if you're following these guidelines correctly, you can access the quick reference of the World Wide Web Consortium. Here, you will find a comprehensive list of criteria and techniques. Accessibility is essential for web development By developing with inclusivity in mind, you can ensure that everyone can access and engage with your content, promote equality, and create a better user experience for everyone around the world.
That was really interesting. So POUR stands for perceivable, and what O stands for? Operable. U stands for something. U stands for uh, usability.
Possible. And finally, R
U
can
stands
avoid
for
understand the information.
understandable.
For example, touchscreens,
Okay.
few.
So here, as we can see, so actually this website here, W3C, is has a page for web accessibility initiative. So here, this is basically for your HTML website or HTML page should be following the universal standard of POUR, P-O-U-R. So this P-O-U-R, P stands for perspective. Yeah, P stands for perspective here. This is WCGA web content. Web content accessibility guidelines, WCGA guidelines for making web content more accessible to people with disabilities. So P for perceivable. So if someone is blind, if we have a screen reader here, they can also understand the sentences written by the screen reader will read each sentence, so they can understand that this website is presenting information about what stuff or what topic it's serving. The O here stands for operable. So it basically operable means basically, so every operable basically means that every element and every button on the page, web page, should be accessible with multiple devices, uh, like from a mouse, from keyboard, and other input devices. Understandable means we should use the sentences as easy as possible. So we should use easier sentences, easier English words, not complex sentences in our program, in our web page. And R stands for robust. So here R is used for robust. So robust means basically our web page should be a robust web page, which means that it should be actually it should be actually supported on multiple browsers, multiple operating systems, multiple softwares. Now, here we can see how to make WCGA quick reference, a customizable quick reference to web content accessibility guidelines, requirements, success criteria, and techniques. Okay, so here it says selected filters WCGA 2.1, all success criteria and all techniques. Okay, text alternatives, non-text content, time-based media, audio only and video only precedence, pre-recorded, sorry, not precedence. Okay, so this is basically where we can find the stuff to make our page more compatible with this WCGA criteria. Now, what is the primary goal of web accessibility? To ensure website to ensure websites are usable by everyone. What are the web content accessibility guidelines? A set of guidelines to make website accessible for everyone. Which of the following is not core principle of web content accessibility guidelines? Compatible, operable is there, understandable is there, perceivable is there. Okay, this is gonna be a long ride. What are screen readers and who uses them?
Readers and who uses them. Screen readers are assistive technology programs that help blind and visually impaired people use computers and mobile devices. Screen readers are not just tools for the blind and visually impaired to access computers and mobile devices. They empower these individuals to access education, work opportunities, and social media. This ensures digital inclusion and enhances their ability to participate fully in society. There's a common misconception that screen readers are text-to-speech devices. However, text-to-speech is just one of the features of a screen reader. Some screen readers even render the text to braille output instead of speech. Apart from text-to-speech and braille output, other notable features of screen readers are navigation aids and web browsing assistants. Screen reader programs are also not only made for blind and visually impaired. Dyslexic individuals and people with cognitive disabilities also use screen readers. All the popular operating systems out there have screen readers built into them. macOS and iOS both have VoiceOver built in. You can turn it on your computer by pressing Command F5. You can access it on iPhones through Settings. Windows computers have Narrator built in. You can turn it on by pressing the Windows key, Control, Enter. Non-visual desktop access, NVDA, and job access with speech, JAWS, are also available for Windows computers. NVDA is free and open source, while JAWS is paid. Linux has Orca for the desktop environment and SpeakUp for the Linux terminal. Android phones have TalkBack built in. You can turn it on by accessing Settings, Special Function, Accessibility, TalkBack. Some Android devices also have Ella and Select-to-Speech built in. One major challenge for screen reader users is that many software developers don't design their products for screen reader friendliness and accessibility in mind. Even though accessibility is a broad topic, every developer needs to learn how to make their web software accessible for the blind and visually impaired, as well as other groups of people with disabilities. This demonstrates empathy and a commitment to inclusivity, ensuring that all users can benefit from their work.
Okay. Which of the following is the screen reader built into macOS? In macOS we have SpeakUp is for I think Linux. Ella is for I think Android. So in macOS we have like VoiceBox or VoiceOver. Let me see.
Built in. You can turn it on as both have them. macOS and iOS both have VoiceOver built in.
Okay.
You can turn it on your computer by pressing Command F5. You can access it on iPhones through Settings. Windows computers have Narrator built in. You can turn it on by pressing the Windows key, Control, Enter. Non-visual desktop access, NVDA, and job access with speech, JAWS.
Deaf people. Screen reader are not for the deaf people, I think. Which of these is not a feature of screen readers? Web browsing support. No? Speech to text. Text to speech. Speech to text. Sorry, that was correct.
What are large text or braille keyboards and who uses them? Large text and braille keyboards are designed for users with visual disabilities. In large text keyboards, also called large print keyboards, The letters, numbers, and symbols are larger compared to standard keyboards. This design is helpful for people who may find smaller text in the keys difficult to read. Most of them also have enhanced contrast and brightness. Here you can see a large print keyboard made by the brand Maxi 8. It has yellow keys with black, big, and bold letters, numbers, and symbols on them. This is helpful for people with low vision.
Yeah.
And this is a black large print keyboard with white print on the keys. This keyboard is also backlit, so users can adjust its brightness to different lighting conditions. While large print keyboards provide visual cues for users with low vision, Braille keyboards provide a completely tactile experience for people with more severe vision disabilities, including people who are blind. Braille is a tactile reading and writing system. It consists of raised dots arranged in specific patterns to represent letters, numbers, and punctuation. Braille keyboards use this system to help users find the right keys on the keyboard by feeling these patterns with their fingers. Here you can see a Braille keyboard made by Logic Keyboard. Notice how the keys have raised dots in patterns that represent the letters, numbers, and symbols. And some keyboards, like this one, combine both approaches. This is a large print and Braille keyboard made by Vision 8 Technologies. It has both large fonts and Braille patterns in the keys, which can be helpful for people with visual disabilities and for people who are learning Braille. Large text and Braille keyboards are tools that empower people with visual disabilities. By providing alternative input methods, these assistive technologies ensure that everyone can be part of the digital world.
Okay. What is the benefit of using a large text keyboard? Of course, it improves the readability of the keys. Who primarily benefits from the use of large text and Braille keyboards? People with visual disabilities. How do people identify letter, numbers, and symbol Braille script? Okay, so feeling the pattern, of course. Next, what are the alternative pointing devices such as talkback, joysticks, and not trackballs? Okay, touchpads. Okay.
What are alternative pointing devices such as trackballs, joysticks, and touchpads used for? Alternative pointing devices are input devices that make good alternatives to the traditional mouse. They are essential for improving computer accessibility for those with disabilities, for limb impairment, and limited mobility. Common examples of alternative pointing devices are trackballs, joysticks, and touchpads. A trackball is a stationary pointing device that consists of a large movable ball within a socket. It also includes additional buttons for clicking and performing other functions. Unlike the traditional mouse, which requires movement around a surface to control a cursor, a trackball remains in place. Users manipulate the ball directly with their fingers, thumb, or palm to move the cursor on the screen. Some traditional mice also have a trackball on the top or side. These mice could be a good starting point if you want to gradually switch to a trackball. Trackballs reduce the physical movement the user needs for navigation, making them ideal for users with mobility issues. Apart from that, if you need high precision and have limited desk space, a trackball is more ideal than a traditional mouse. A joystick is a pointing device primarily designed for games and certain industrial applications, such as machinery control. It consists of a lever that pivots up, down, left, and right, and often includes additional buttons for various actions. Joysticks provide precise control over movement and actions within digital environments. This makes them popular for flight simulators, cranes, driving games, and other applications requiring precise directional input. Because joysticks accommodate larger and more deliberate movements, they are beneficial for individuals with tremors and unsteady hands. They also reduce the strain and pain that comes with repetitive movements, making them ideal for individuals with arthritis and carpal tunnel syndrome. A touchpad is a flat, touch-sensitive device built into laptops and some keyboards. It allows users to control the cursor on the screen by sliding their fingers across its surface. Apart from the surface for cursor control, touchpads also feature buttons that emulate the actions of a traditional mouse, such as right-click and left-click. Most people see touchpads as a better alternative to a mouse because they significantly enhance navigation by supporting multi-touch gestures like pinch to zoom, two-finger scrolling, tap to click, and three-finger swipes. Touchpad is ideal for individuals with low arm or hand movement because the forelimb is almost always stationary while using it. It is also suitable for people with arthritis and joint pain because they don't need to move their arms too much.
All known. What kind of device are trackball, joystick, and touchpads? They are all input, pointing, and video. Pointing devices? Okay. Which device supports multi-touch gestures like pinch to zoom? Of course, it is touchpad. Which pointing device is primarily designed for games and specific industrial applications? Joystick? Correct. Let's submit. What are screen magnifiers used for? Of course, these
What
are
are
just
screen magnifiers used
not
for?
that important.
Screen magnifiers are tools that help people with low vision and other visual impairments to have better access to digital content and the web. Let's dive deeper into what these tools are and the role they play in digital content accessibility. Screen magnifiers work by enlarging text, graphics, and other elements on a computer or mobile device screen. Many screen magnifiers allow users to enlarge the display by more than 2,000%. Users can then navigate the page using their pointing device or keyboard. Additionally, most magnifiers offer customizable zoom percentages and other features in their settings. Screen magnifiers primarily help people with low vision read text, as small fonts in documents or applications can be challenging for them. By enlarging the text, they can read emails, articles, and other content without straining their eyes. Screen magnifiers also assist with web browsing. They help users locate and click on buttons, links, and other interactive elements that might be difficult to see. This improved visibility ensures that users can browse websites, fill out forms, and engage in online activities without difficulty. Therefore, software developers need to make their digital products accessible to people with low vision. Some considerations include using scalable fonts so the user can resize the page without the layout breaking, ensuring the user interface adapts to different screen sizes through responsive design, using high contrast color schemes and customizable colors, implementing a non-sticky and tiny navbar so users can still see content when using magnifiers, using regular HTML text instead of images of text, and providing feedback directly next to the element that triggers it, and more. All the mainstay operating systems have at least one magnifier built into them by their manufacturers. macOS and iOS both have Zoom. To turn it on macOS, go to your settings, filter by Zoom, and there you will see a setting that you can enable. Use keyboard shortcuts to zoom. Then you will be able to use the keyboard shortcuts Option Command and the equal sign to zoom in, and Option Command the minus sign to zoom out. Android devices have magnification. To turn it on, go to Settings, Special Function, Accessibility, Magnification. Since this may vary from device to device, you can search for magnification on the settings homepage to access it. Windows has magnifier. You can use it by going to Settings, Ease of Access, Magnifier. The magnifier for Linux operating systems vary. It is either zoom or magnifier. Apart from the ones built into operating systems, some useful third-party screen magnifiers are Zoom Text for Windows, Claro View for both Mac and Windows, iZoom for Windows, Zoomify screen magnifier for Mac, Lunar Pulse for Windows, and Loop for Mac.
Okay. How do most screen magnifiers work? By enlarging the text and graphics and other elements on a computer or mobile device screen. Which of these should a developer do to make their digital product friendly to screen magnifiers? This is the correct option. Which of the following is a third-party screen magnifier? Loop. Loop is not? What? Okay. What is voice recognition software used for?
What is voice recognition software used
Easy.
for? Voice recognition software helps people with disabilities interact with computers and other digital devices. Let's discuss what voice recognition software is and the role it plays in digital inclusion. In the context of accessibility, voice recognition tools let people with disabilities use their voice to pass commands to perform various tasks, instead of using traditional input devices like keyboards and mice. This includes writing emails and other documents, surfing the net, and controlling smart home devices. Because voice recognition software tools eliminate the need for physical interaction, they empower people with disabilities with significant independence and control over their environment. Here are the specific people who may find voice recognition software significantly helpful. People with visual impairments, including those with low vision or blindness. Individuals with mobility impairments, such as limited use of hands and arms or conditions like arthritis and carpal tunnel syndrome. Those recovering from hand or arm injuries. Individuals with cognitive disorders like memory issues or attention deficit disorders. Elderly individuals who might find it easier to use voice commands. Note that people with disabilities are not the only ones who use voice recognition technology. Law enforcement agencies, gamers, drivers, and busy professionals also use voice recognition tools. A few examples of voice recognition software that allows people to interact with their computer include voice control for macOS and iOS, voice access for Android, and Windows speech recognition for Windows, referred to as voice access in most recent versions of Windows. Dragon by Nuance is a popular third-party voice recognition software for Windows.
Okay. What are the main input devices that voice recognition software replaces? Image read fingerprint readers? Keyboard and mouse, of course. Which of the following would be the least likely to benefit from voice recognition software? People with low leg movement. Yeah, maybe this one is the low leg movement. Elderly people. Mobility impairment, they will definitely benefit from this. Elderly people will also benefit from voice recognition software. Now, if you talk about people with low leg movement, this doesn't, I don't know what does this means. People with visual impairment will also definitely get benefit from voice recognition software. So, which of the following is not a voice recognition software here? If we look at this, I think voice access is not one of the voice recognition software. Of course it is. Dragon is also, brah, Audacity, the correct answer. Okay, what are some common accessibility auditing tools to use?
What are some common accessibility auditing tools to use? Accessibility is a crucial yet often overlooked aspect of digital content. When making your digital content accessible, it's important to ensure it meets accessibility standards. An accessibility auditing tool is an application that helps you improve the accessibility of your digital content by reporting accessibility issues that can be easily found through automated testing. This content includes websites, web applications, and mobile apps. It is important to note that while automated accessibility tools have a role in improving accessibility, they typically will only find about a third of all possible accessibility issues. Therefore, it is important not to rely on them entirely to evaluate the accessibility of your content. Manual testing, preferably by people with disabilities, will always be required to ensure that your content is as accessible as possible. Let's look at some free tools that can help you improve the accessibility of your digital content. Google Lighthouse is a popular web metric checker that you can use directly within Chrome DevTools or online. This means you can check not only live websites, but also locally developed ones. The metrics you can check include accessibility, SEO, best practices, and performance. To use Lighthouse, open your DevTools by pressing F12 and switch to the Lighthouse tab. Select the metrics you want to check, choose the device you want to test on, and click the Analyze Page Load button. An accessibility score will appear after the check is complete, along with a list of any issues that need fixing. If you want more reliable metrics, consider using the web version. The downside is that it doesn't support testing local websites. You can access the web version on pagespeed.web.dev. Wave is another reliable accessibility checker that you can use as a Chrome extension or on the web. All you need to do is enter the URL of your website, and a comprehensive accessibility report will be generated for you. This report includes accessibility features implemented, ARIA, and contrasts. The IBM Equal Accessibility Checker is another robust tool for improving digital content accessibility. With this tool, you can scan your websites for accessibility issues and generate a detailed report. You can use it as a Chrome extension or Firefox add-on. To use the IBM Accessibility Checker as a Chrome extension, download it from the Chrome Web Store, open your DevTools by pressing F12, and select the Accessibility Checker tab located in the Elements panel. Click the Scan button to start the check, and a report will be generated for you. You can export the report as a spreadsheet and an HTML file by clicking the Export XLS checker that you can use as a Chrome extension.
Wait a minute.
Issues that need fixing.
Okay.
Device you want to test on, and click the Analyze Page Load button. An accessibility score will appear after the check is complete, along with a list of any issues that need fixing. If you want more reliable metrics, consider using the web version. The downside is that it doesn't support testing local websites. You can access the web version on pagespeed.web.dev. Wave is another reliable accessibility checker that you can use as a Chrome extension or on the web. All you need to do is enter the URL of your website, and a comprehensive accessibility report will be generated for you. This report includes accessibility features implemented, ARIA, and contrasts. The IBM Equal Accessibility Checker is another robust tool for improving digital content accessibility. With this tool, you can scan your websites for accessibility issues and generate a detailed report. You can use it as a Chrome extension or Firefox add-on. To use the IBM Accessibility Checker as a Chrome extension, download it from the Chrome Web Store, open your DevTools by pressing F12, and select the Accessibility Checker tab located in the Elements panel. Click the Scan button to start the check, and a report will be generated for you. You can export the report as a spreadsheet and an HTML file by clicking the Export XLS button. Please keep in mind that while these automated tools help you make your content more accessible, a perfect score from any of them does not mean that your content is entirely accessible. The range of issues that these tools test for is limited, and manual testing will always be needed to ensure a more accessible experience for everyone.
Okay, yes. Which of these best describe an accessibility auditing tool? It automatically fixes all the accessibility? No, it evaluates how accessible your web page or digital content are. Actually, this is the correct answer. Okay, let's go. Which of these describes how can you use the IBM Equal Access Accessibility Checker? It can be used as a Chrome extension, Firefox add-on, or NPM package. Which of these is a limitation of using web version of tools on the Google Lighthouse? It provides underlying metrics. It can also test the website. It doesn't support mobile testing. Which of these is limitation of using web version of the tools on Google Lighthouse? It provides unreliable matrices. It can also test. Okay, I think this is no. Google Lighthouse. Where the fuck is the Google Lighthouse?
Accessibility checker that you can use as a Chrome extension or on the web. All you need to do is enter the URL of your website, pressing F12, and switch to the Lighthouse tab. Select the metrics you want to check, choose the device you want to test on, and click the Analyze Page Load button. An accessibility score will appear after the check is complete, along with a list of any issues that need fixing. If you want more reliable metrics, consider using the web version. The downside is that it doesn't support testing local websites.
Local websites. It cannot test local websites. Check. Let's go. How does proper heading level structure affect accessibility? Proper heading level structure affect the accessibility. Okay.
How does proper heading level structure affect accessibility? In an earlier lecture video, you learned about proper heading level structure. In this video, you will learn how a good heading structure affects accessibility. Proper use of headings creates a visual hierarchy for users to navigate and understand your web page. Using a logical heading hierarchy allows screen reader users to understand the structure of your content and navigate your content quickly. Creating appropriate heading text that accurately describes the content that follows helps everyone find the information they need on your website. As an additional benefit, well-formed headings may also improve the SEO of your website. Think of headings as the foundation of your site. Without a good foundation, the accessibility of your content will suffer. Let's look at how you can make your web projects friendly for people who use assistive technologies by using headings correctly. Headings ranging from H1 to H6 create a navigational structure for screen reader users. Screen readers can list all headings on a page, allowing users to jump directly to the sections they need. So correctly arranging headings is important for helping these users avoid unnecessary content and find the information they are looking for quickly. People with
Hello, hello. Okay, so let's resume here. Let's take it a bit back here.
for people who use assistive technologies by using headings correctly. Headings ranging from H1 to H6 create a navigational structure for screen reader users. Screen readers can list all headings on a page, allowing users to jump directly to the sections they need. So correctly arranging headings is important for helping these users avoid unnecessary content and find the information they are looking for quickly. People with partial sight or cognitive disabilities need to process information quickly and easily to reduce cognitive load. While proper arrangement of headings is important, it is also necessary to make heading texts clear and descriptive. Here are some key practices to follow to use headings properly. Use headings in a hierarchy that reflects clear organization. For example, the page title should be an H1. Major sections should be introduced with H2 headings, subsections with H3, and so on, down to H6. Don't skip from H1 to H3 or from H2 to H4 and so on. Use clear and descriptive text that summarizes the content that follows the heading. Don't use a heading in isolation. Some content must follow the heading. Use appropriate headings where necessary, instead of formatting text to look like a heading. Each page should have a single H1 element representing the main topic or title. Here is a basic markup that represents how you should use headings on a page.
Okay. It says the second question is why it is important to use headings properly for users who rely on keyboard. It is important, it improves the visual appeal of the web page. It allows users to print the web page more easily. It lets user to jump through section without needing to have the, yeah, yeah, this is the correct answer. Which of these is one of the best practices of using heading on a web page? Skipping H1 to H no, using cleared and descriptive to summarize the use lead. This is the correct answer. What are the best practices for tables and accessibilities? Okay.
What are best practices for tables and accessibility? When we see a table, we immediately start making visual associations between the data and the headers, right? For example, let's say that this table is a representation of our pets. We have
Okay.
2 dogs and 2 cats, and the table is showing us their names and ages. While a sighted person may be able to understand the relationships in this table,
Yeah.
making the connection between the values and the headers is much harder for people who use screen readers to navigate the table.
True, true.
As a web developer, you are in charge of creating these associations and structuring your HTML markup in a way that is also easy for screen reader users to interpret.
Okay.
So let's see how you can create accessible tables that everyone can understand. The first best practice that we will cover is using table captions. With the caption element, you can write the caption or title of a table so users, especially those who use assistive technologies, can quickly understand the table's purpose and content. You should place the caption element immediately after the opening tag of the table element. This way, screen readers and other assistive technologies can provide more context by announcing the caption before reading the content.
Okay.
Now let's talk about row and column headers. Headers are special cells, typically found at the start of a row or column, that describe the type of data stored in that row or column. You can define a row or column header with the table header element. For example, here we have a table with 2 pets. Every row has a row header, the name of the pet, and every column has a column header, which describes what the data in the column represents, age and type. This is the same table in HTML. Notice that it has a caption element immediately after the opening table element. Then, inside the table head element, it has the column headers, name, age, and type. In the second and third rows, inside the table body element, we find the data of each one of our pets. The names of the pets are the row headers because they are inside table header elements, TH. Associating the data cells with their corresponding headers is also very important for screen readers. The scope attribute determines if a header is a row header or a column header. Screen readers may guess this correctly from the table structure, but it's usually recommended to explicitly indicate the scope to ensure clarity. The scope attribute has 4 possible values. The 2 that you will use most often are col for column and row for row. Here you can see that we added the scope attribute to the column and row headers. The 3 column headers, name, age, and type, have a scope of column. The 2 row headers, Nora and Gino, have a scope of row.
Okay.
If a column or row header spans across multiple cells, the scope will also be applied to each one of the cells individually. Here is an example of that. In this table, the cell with Nora's age, 5, will have 1 column header, age, and 2 row headers, dogs and Nora. Gino's age, 2, will also have 1 column header, age, and 2 row headers, dogs and Gino.
Okay.
However, some screen readers may not be able to interpret tables with these complex structures, so you should try to flatten the table as much as possible to avoid row and column headers that span across multiple cells. Your goal should always be to make sure that users can access this information, even if their screen readers can't handle complex table structures. Now, for cell width, it's recommended to avoid using fixed values. You should use relative values instead, like percentages. Also, try to avoid defining cell height. This will allow users to adjust text size to fit their needs. And finally, you should let the browser determine the table width whenever possible to reduce the need for horizontal scrolling. HTML tables are essential for presenting structured data in an accessible and understandable format. By following these accessibility guidelines, you can create tables that are easy to understand for everyone.
Okay. Which HTML element is used to specify the title of a table? Caption, actually, is the correct answer. What is the purpose of scope attribute in a table header th? To specify the no, to indicate whether the header applies to row or column is the correct answer. Which of the following is the best practice for creating accessible tables? Best practice for creating accessible tables? Not providing alternative text. Best practice for creating accessible tables. Using simple table structures with row and column headers is the correct answer. Check. Correct. Let's go. 39% completed.
Why is it important for inputs to have an associated label? Labels on input fields might seem like small details, but they play a crucial role in making forms easier for everyone to use. Labels help people with disabilities make forms more user-friendly for everyone and ultimately improve form conversion rates. Let's dive into why adding labels to input elements is important for accessibility and usability. Screen readers often rely on labels to describe the purpose of input fields. In order for this to work properly, the label must be programmatically associated with the input. While there are several ways to do that, the most common one is to use the HTML label element. Here's how to associate a label with an input. In this example, the for attribute of the label element is associated with the ID of the input element. This connection allows screen readers to announce the label when the input is in a focused state, allowing screen reader users to understand the purpose of the input. Associating labels with all input fields also benefits SEO, search engine optimization. With proper labels, search engines will understand the page content better, leading to a positive impact on the page search rankings. But it is important to understand that you're making content for humans, not search engines. So you should make sure the labels are as clear and descriptive as possible.
Wow, that was really helpful. Why is adding label to input elements important for accessibility? They provide visual styling into input fields. Actually, this is actually good answer. How do labels associated with input fields improve keyboard navigation? They allow users to tab through the input field without getting lost. They reduce this one. How does labels associate with input fields with the help of identify anchors? They allow input field to they help the screen reader announce the label to prevent user from submitting to make the input field more. Of course, second. Everything is second. Okay, we are really close of 50%. What is the purpose of WAI ARIA and how does it work? What the fuck is
the purpose of WAI ARIA and how does it work? Making static content accessible can be relatively straightforward, but dynamic content can be more challenging. This is where WAI ARIA comes in. Let's look at what WAI ARIA is, its purpose, how it works, and some examples. WAI ARIA stands for Web Accessibility Initiative, Accessible Rich Internet Applications. It's a specification that enhances accessibility for dynamic content and user interface components. Note that WCAG and WAI ARIA are not the same. WCAG provides general guidelines for web accessibility, while WAI ARIA offers specific rules for making dynamic and interactive content accessible for users of assistive technologies. So the primary purpose of WAI ARIA is to improve accessibility for dynamic content and UI components that do not have native HTML equivalents. WAI ARIA works by introducing a set of attributes. You can add HTML elements to provide additional semantic information. These attributes are categorized into roles, states, and properties. ARIA role defines the purpose of an element within a website or web app. Here is an example of setting the role to button for a div element. By doing this, you're indicating to the assistive technology that the element is a button. Roles do not provide any functionality, however. Merely giving this div a role of button will not make it act like a button. To make it look and behave like a button, you would need to use CSS and JavaScript to get the desired result. It is always better to use the native button or input element with type button instead. Since HTML alone does not provide a way to make custom user interface components like tab navigation, tab list accessible, ARIA roles can be very helpful. Here is what a tab list could look like with the role attribute. Each tab in the tab list will have an associated tab panel that will display when its tab is selected. Each tab panel will have a role of tab panel. Here's what each one of those tab panels could look like. ARIA state describes the current status of an element, which can change based on user interactions. An example is the ARIA expanded attribute for collapsible sections. Again, this is merely describing the state. It does not provide any functionality. You would have to use JavaScript to change the state of the attribute when the user clicks the button. ARIA properties provide additional details about elements. For example, the ARIA labeled by property lets you connect an element to a specific label. This will make the elements understandable and navigable for users of assistive technologies. To get the best out of WAI ARIA, try to stick with native HTML whenever possible, since it generally provides more accessibility out of the box. Use WAI ARIA only when HTML falls short. And don't forget to test with assistive technologies like screen readers. Also, make sure your WAI ARIA states and properties update with the content in real time. Avoid overusing ARIA as it can be confusing many times.
Okay. What is the primary purpose of WAI ARIA attribute in HTML? To change the visual appearance of elements, to provide additional semantic information for accessibility, to display tooltip on elements, to add animations to elements. Okay, and what is the primary purpose of WAI ARIA? Of course, this is actually. How does WAI ARIA works to enhance web accessibility? By introducing attributes that provide additional semantic information. Stands for Web Accessibility Initiative, Advanced Response and Internet Applications, Accessible, Accessibility in Richness, Accessible resource internet application. I think this is the correct answer. No? Okay, man. That's that's the correct answer. Accessible rich internet application. Accessible rich internet applications. Web Accessibility Initiative. ARIA. ARIA. Accessible rich internet application. Okay, 48% complete. Let's hop on to another one. What is ARIA roles?
What are ARIA roles? ARIA stands for Accessibility Rich Internet Applications. ARIA roles specify the semantic meaning of HTML elements. They're essential for making web content accessible to people who use assistive technologies like screen readers. HTML has semantic and non-semantic elements based on whether they convey meaning about their content. Many semantic HTML elements already have an ARIA role assigned by default. For example, the button element has a default ARIA role of button, but non-semantic elements don't have a role. For example, screen readers will not know how to interpret the purpose of a div if you don't specify its role explicitly. To specify the ARIA role of an element, you just need to add the role attribute, like this, where value is the name of a role in the ARIA specification. It is important to note that specifying a role on an element only does one thing. It informs assistive technologies of the purpose of the element. It does not add any functionality or behavior to the element. If people expect a role to behave a certain way, it is up to you, the developer, to add that expected behavior. For example, adding a role of button to a div does not automatically make it clickable with a mouse or usable with a keyboard. It is the responsibility of the developer to add the expected behavior that allows the div to act like a button. And in most cases, it is just better to use the button element. There are 6 main categories of ARIA roles: document structure roles, widget roles, landmark roles, live region roles, window roles, and abstract roles. Let's take a look at them in more detail. Document structure roles define the overall structure of the web page. With these roles, assistive technologies can understand the relationships between different sections and help users navigate the content. However, most of the document structure roles are not used in modern web development because browsers already support equivalent semantic HTML elements, which should be prioritized whenever possible. You should specify the roles that don't have an equivalent semantic element. For example, toolbar, tooltip, feed, math, presentation, none, and note. There are other similar roles, but these are the most commonly used ones. This is an example of a div with a math ARIA role. The div contains a mathematical equation. You'll also notice that the div has an ARIA label attribute. The value of this attribute should be a string that represents the expression. Widget roles define the purpose and functionality of interactive elements, like scroll bars. Examples of widget roles include scrollbar, search box, separator when focusable, slider, spin button, switch, tab, tab panel, and tree item. Some of these roles have equivalent semantic elements. You should prioritize the semantic element over the role if there is one. For example, you should favor using the HTML button element over adding a role of button to a div. Landmark roles classify and label the primary sections of a web page. Screen readers use them to provide convenient navigation to important sections of a page. You should use them sparingly to keep the overall layout simple and easy to understand. Examples of landmark roles are banner, complementary, content info, form, main, navigation, region, and search. Each one of these roles has a corresponding HTML equivalent, such as header, footer, aside, form, main, nav, section, and search. If you use the proper HTML elements to define the sections of your page, then it is not necessary to explicitly add the role attribute to these elements. Live region roles define elements with content that will change dynamically. This way, screen readers and other assistive technologies can announce changes to users with visual disabilities. These roles include alert, log, marquee, status, and timer.
Okay.
Window roles define sub-windows, like pop-up modal dialogues. These roles include alert dialog and dialog. Please note that it is now considered a best practice to use the HTML dialog element and its associated JavaScript methods instead of manually creating a dialog. And finally, we have abstract roles. These roles help organize the document. They're only meant to be used internally by the browser, not by developers. So you should know that they exist, but you shouldn't use them on your website or web applications. With ARIA roles, you can create accessible and inclusive websites and web applications. They provide semantic information about the purpose and function of HTML elements. Screen readers and other assistive technologies use this information to help users understand the content of your page and set expectations for how to use it, which helps
Okay.
ensure that everyone can have a great user experience.
Okay, that was too much information. What is the primary role for ARIA rules? It defines the visual appearance of the elements, it improves the website performance, it provides the information about purpose of the elements, it enhances browser compatibility. It provides the semantic information about the purpose of the element. Which category of ARIA rules is used to define the purpose of the behavior of the subwindows, like pop-up modal dialogues, widget roles, widget. Which category ARIA rules is used to indicate dynamic content must be announced by users? Okay, correct. This is not correct. Okay. Which of the following categories define the purpose of behaviors of sub windows, like pop-ups, window roles? Correct. Okay, so I think I should stop.